Good morning. It's 35 degrees, a little cloudy, a little nippy this morning. We're here in the Freedom 450 at another mine site. We're gonna hook up that 40 horsepower motor on that scalper. We're just doing it temporarily with a SO cord. That's what they want. And right over here behind me is the MCC room. There's a bunch of old equipment in there and stuff. So we're gonna hook it up to an existing VFD, variable frequency drive, run a cord and get it going. And then there's a belt over there. They're gonna bring a underbelt, put it in right here, and we're gonna hook that one up too. All right, stand by. All set up here already. Got the cord, generators running. Got power in the cabinet. So I got some lights in there so I can see. So let me take you in there and show it to you. This is the MCC room. Of course, it's old. It's been here a long time. All the power's off right now, but we're gonna go ahead and use this existing circuit. It's on a 200 amp three-phase breaker. We're gonna put 150 amp fuses in it. We're gonna run an SO cord over to this VFD that's existing to power it up. And then we're gonna take the new SO cord back out of the bottom of the trailer and run it over and hook up that scalper out there. All right. It's pretty dusty. Really. I'm gonna go get a vacuum. Stand by. We're gonna have to blow that out. That's pretty bad. I'm gonna have to get the big guns out. Get the ground hooked up. pull test it. It's good and tight. I missed it. That's why you always pull test it. I put the wire behind the lug and not inside of it. There we go. Okay, I got the line side wires all done. We'll put three 250, or I'm sorry, 350 amp fuses in there. That's what the main is for a 40 horse motor. Stand by. Okay. Okay, got the fuses in there. We're going to go ahead and hook up the disconnect. Real quick, so this is 483 phase being fed in here. This is a 200 amp disconnect. We're going to power a 40 horsepower motor through the VFD, the variable frequency drive. So I've sized down the fuses to 150s. We're going to run a cord over to feed the drive to turn it on, and then we're going to take another cord out because it's temporary and run it out to the motor. So I'm going to wire in the feed power, the line side, from the disconnect over to there, and then I'm going to go turn the power on and we'll see if that drive even works. I don't even know. With three-phase motors, they can run forwards or backwards, 50-50, depending on which way A, B, and C phase is wired. So I have a rotation meter I can put on if it's critical. If the motor has a brake or something on it and it can't run backwards, we can see which way the current electricity is rotating and hook it up that way. But on this we have a drive. So on the VFD drive we can just reverse it with the push of a button on the drive. We could also, if the motor was going backwards, you just take two legs off, switch them, positions, and put them back on, and it'll run the other way. Okay, that's all hooked up. I'm going to double check the fuses and make sure they're not blown, which they're pretty sure they're not. I checked them last time I was here, a couple weeks ago. Just take my continuity tester. That one's good, good. We're good, okay. Now I'm gonna go turn the power on and we'll turn power on to the drive and see if it turns on. So we're gonna turn the power on over there. There we go. Power is now on to our MCC trailer over there. Stand by. They're moving that conveyor over now. They're going to put that conveyor underneath there coming this way, and I got to wire the motor there. We're going to go up and wire that motor next. Turn the power on. Let's check it out. This is the disconnect that feeds power to that drive. All right, we got 480, power's on. Good to go. Okay. Stand by. See if this drive turns on. She turned on. Can't even believe it. Beautiful. It's got a fault because I got to go hook up the motor. So we're going to hook up the motor and then we'll come turn it back on. Stand by. I'm going to go ahead and do the ground wire first because it's the furthest thing back in the wiring compartment, or peckerhead we call it. That way I can tuck it back in there and not worry about the other wires rubbing on it or it passing over the top of the other wires and causing a rub, which would strip the wires and then cause a short eventually. You got to be mindful of how you put wires inside here so they don't rub, and depends on what the motor's doing. If you've got a motor that's on a shaker or a vibrator, then you better really pack it down with some good insulation inside. This is just a standard conveyor motor, so it's not going to have a lot of vibration compared to others. Tuck that down out of the way. Now we'll go ahead and do each conductor. Gonna fix up my wires so they're not, so one isn't leading the other like by a bunch like that, you know. I like them, you need them to be even so that the wire nut grips them good. This is probably the biggest motor we'd use wire nuts on. Any bigger and we use insulated connectors with lugs. But this is a small motor. These are small wires. I'm going to go ahead and use these gray wire nuts. In my world, tan wire nuts are your standard, like 12 gauge. Then gray is the next size up, and then you got these big blue ones you can get for stuff even bigger. So there's one. See, this one here is T12 and T1. So that's going to go to a line also coming in. I'm going to fix these up, make sure they're looking good. Not all. If there's a lot of wires missing that broke off, then I'll re-strip them. But right now it's looking good. Again, it doesn't matter what phase I go to. The motor will either go forwards or backwards. And if it goes the wrong way, then I'll switch one of the wires down in the MCC room on the motor starter. I'll reverse 2 wires and then the motor will spin the other way, so I don't have to come back up here or any of that. Again, check them. You can't check them enough. 3 and 11, yep. 3 and 11 go together to a conductor. This one's missing a lot of conductors, so I'm going to strip it again. I don't know if you can see it from there, but there's only a few left. So we're going to make that one fresh. This one's really good still. I'm pulling the wires. If the wire's all looped around, going around other wires and stuff, take it out and make it less loopy, so to speak. That way it doesn't rub. We'll go ahead and tape these up just to ensure they don't come apart from vibration. It's pretty chilly this morning. It's 30 degrees. Beautiful day though. You see that sun coming up over the hill there. Tape is a little stiff, black tape. So give it a good stretch when I put it on, and it warms it up from stretching. It warms it up a little bit so it sticks better. Okay. Go around the wire nut. When you start here and you go up over the wire nut, it doesn't really stick. You get like one wrap onto the wire nut because the wires are so much smaller. So I go up over the wire nut. I go up over the wire nut and then back down over the wires again. Then I know it's on there real good. All right. The other wires are taped up real good already. Everything looks good. I'm going to throw a zip tie on it just to kind of keep them together. Then I can manage how they rub. If you don't do it, they'll rub on the cover and you'll have a short. They can rub against each other too. If you zip tie them all together real tight, they can rub against each other and short out. So I'm going to go ahead and put this together this way, manage it a little bit. That's not going to work, is it? Okay. The top of the cover's got a bump, so up here we got more space for those wires to sit. Good. Gonna go get some more screws. Stand by. These screws are awesome. They will drill through 1/2-inch steel, and they're fine thread, so they stick, they stay. Coarse thread screws vibrate out, but these are perfect for this sheet metal motor cover. Finished tightening these up because I didn't tighten them because I wanted to leave space. You know, if you've got multiple screws and you tighten one, then the other ones might not line up because the hole isn't where it needs to be for the threads. You know what I'm saying? You guys know what I mean. All right, we're gonna put this SO cord, we're gonna strap it along this conveyor. Stand by. By the way, we've been working on an extension ladder. It's a beautiful day up here. Truck's down there. Sunrise is over there. We're gonna run this SO cord and strap it on those unistruts all the way down. And then we're gonna follow that other SO cord out of the way so these guys don't snag it while they're running. Stand by. I'm taping up the wire so it doesn't rub through on the connector. That way the clamps onto the wire and any little vibration's not going to rub through. Starting to warm up. I'm going to take my beanie and jacket off. Stand by. Got that SO cord all stretched out. This is temporary to see if we can get this motor running. So we're going to make a splice over here temporarily, and then we're going to make one more splice there because they wanted to save money and use the cord that they had. So we're going to splice it there, and then we're going to go inside and fire it up. Stand by. We're going to start in here so we can test that little 20 horse motor now that it's all hooked up temporarily. I got to go outside and check the buzzer. The safety buzzer didn't work yesterday. Let's go check it out. It's right here, hanging upside down. Got to kick the tire on it sometimes, you know what I'm saying? Smack the dirt out of it. Let's go test it now. Turn power back on. Power's on, so you got to watch out. All this is live. All that aluminum you guys see is got power to it. Can't see it. You can't smell it. You can kind of hear it because this transformer's buzzing. Power's off. Maybe they turned the main off. I'll go check. Stand by. I turned the main off when I left the other night. There we go. Got to be gentle with the boot. Now we got power. You can hear that transformer. Listen. But otherwise, if you weren't paying attention, you wouldn't know. 480. Power comes in, that cable right there comes up, goes to the top of that circuit breaker, then it comes out, goes to this soft start. That's for the jaw or the cone crusher, which they're not using. And then they've tapped off of it over to this bus, and then that's what powers everything else up in here. Nothing's gonna work except for our motor starter right here for that 20 horse. And I didn't use any of the breakers in here. These black wires right here coming out were already landed on a circuit breaker right here. So I put my motor on that 50 amp breaker right there. And it comes over here and goes directly to that motor starter, goes out the motor starter. Now I want to test that horn. When you pull the main power button, it starts the time delay, which sounds the horn for however long. I got it set to like 15 seconds. It sends power to the horn sounds, and then when the horn stops, it lets power through another contact back up to the starter switch on the board, so then they can start the belt. That way they cannot start the belt unless they sound the horn. But the horn's not working. See that? There's power going to that horn right now, but it ain't working. So I gotta go get another one and try it out. I'm gonna turn power back off since we're not gonna be messing around in here. Okay. Power's back off. Let's see if I can find another horn. Stand by. Okay, I'm going to test that buzzer again. There it is. Pretty cool. So how that works is, so when I turn the switch on here, it sends power down to number 2. I got neutral on number 7. And then it starts the time delay. Now when I turn power on, when I pull the button, the horn will sound. And you can see, this is the button I have that goes to that mag starter. It's not working right now. And it won't work as long as the buzzer's, when the buzzer's done, then it'll work. Now I'm going to push this. You'll be able to hear that contactor kick on. There's kick on. See that? On, off, on, off. Did you turn off that main button? You can't start that belt unless you sound the horn. Let's see if that motor's any good. Should be running. Let's go check. Yep. She's running smooth. It's hard to tell from here. I can see it, and it's running backwards. So I'm going to go switch a phase, and we'll come back and make sure it's running forward. All right, turned off the circuit breaker, turned off the main power. Power's off. Okay, we're going to go ahead and switch to these legs so the motor spins the other way. Alrighty, that's done. So that's all ready. I'm going to go ahead and tell them I need to test the shaker motor now. Stand by. Looking good.